Hello everyone, welcome back, and this will be the continuation of the worksheet on trial and improvement together with inequalities. Okay, without further ado, let us proceed. So we have a question over here which says draw a ring around the inequality represented on the number line. Okay, so you can see here this is a closed circle. This is a closed circle, and this closed circle suggests less than or equal to or greater than or equal to. You can see an open circle, and this suggests either greater than or less than. Okay, so the inequality we see here is represented by this number line, and this shows all the numbers which are between -4 and +2. Now, because this is the closed circle and this is the open circle, this will mean we have to represent all the numbers which are between -4 and +2, and all these numbers are represented by letter X. And because this symbol is this symbol is an open circle, this will suggest X is less than 2 and -4 is less or equal to X. So the inequality which has to be ringed up will be this one here. This is the inequality that represents this number line. -4 is less or equal to X, and X is less than 2. I hope that helps. We have another question here, which is solve the inequality y/6 is greater than 1.5. So we have y/6 is greater than 1.5. Now we have a denominator here, so what we do, we remove this denominator by multiplying by 6 on both sides. You multiply by 6, this and this will cancel, and therefore you are going to remain with y is greater than, then 1.5 times 6, this will be 9.0. So y is greater than 9.0, which you can cancel that. That is simply 9. Okay. All right. Let us continue. This is the solution. Y is greater than 9. All right. Now suppose we want to show this solution on the number line. Okay, suppose we want to show this solution on a number line, y is greater than 9. What we do, we simply understand the meaning of this symbol greater than. Now this will suggest you have to use an open circle. Okay, and the starting point will be on 9 itself. So this is 9. Y suggests all numbers which are greater than 9. Those numbers which are greater than 9 include 10, 11, 12, 13, 14, and so on. Okay. Now, starting from 9, here we keep an open circle. Why? Because the symbol is greater than. And then you take your ruler, you join from this point here. Take your ruler, all the numbers which are bigger than 9 are all these numbers here. And you write that these are all numbers which are bigger than 9. Okay? Good. We have the next question here. Here is a number line. The question is, tick which of these inequalities is shown on the number line. All right. So let us see. Now this number line you see here represent all the numbers which are between -2 and 5, all the numbers which are between -4 and 5. So here uh, let those numbers be represented by letter n, for example. So those numbers which are between -2, which is this number, and +5, which is that number. So these will be represented as, you can see a closed circle over here, and you can see an open circle over here. So this suggests that those numbers will be less than or equal to 5, and -2 will be less than those numbers. This n stands for all numbers which are between -2 and +5. And the inequality that represents that number line will be this one here. -2 is less than n, and n is less or equal to 5. So you tick this box over here. Okay. Right. Then let us proceed. The next page is this page over here. Now this question is talking about trial and improvement, and the question says one solution to x squared plus 3x equals to 17 is between 2 and 3. So we have the interval over here that one solution is between 2 and 3. Okay, so the first interval is this one here. We have 2, we have 3. So we have to try all the numbers which are between 2 and 3 and see which number will give us the answer equal to 17. So for now we have to store this function here, y equals to x squared plus 3x. We have to put this function in our calculator. Right, this is the calculator. Let us store this function in a calculator. So we have y equals to x squared plus 3x. Right, so we have to calculate. We have to calculate for x equals to 2 and x equal to 3, and that has been done for us. When x is 2, we got the answer equals to 10, which is smaller compared with this answer over here. Okay, and when x is 3, we got the answer 18, which is bigger than the expected, and the expected answer here should be 17. Okay. All right, now let us try the numbers between 2 and 3. Those numbers, we first start with the number exactly at the middle of 2 and 3, and this is 2.5. So we have to try 2.5 and see how much do we get. So try 2.5. Okay, 2.5. Okay, we are getting 13.75. So for x equals to 2.5, we are getting the answer 13.75. So 13.75. Okay, and this is smaller than 17. Okay, and we try, since that is smaller, then we have to head over to numbers which are higher than 2.5, and these are 2.6, 2.7, and so on. Right, so substitute over here, substitute 2.6, for example, and you'll be getting 14.56. be getting 14.56 when x is 2.6. Now let us try for 2.7, because 14.56 is not equal to the expected. It's still smaller. It's still smaller than the expected number. Okay, so now let us try 2.7. Calculate the value of y when x is 2.7. 2.7. 2.7 equals to 15.39. So 15.39 is still smaller than the expected. And then we try 2.8. Calculate y when x is 2.8. We get 16.24, and this is still smaller than 17. So we have to try 2.9. So try 2.9. We are getting 17.11, which is bigger than the expected. So now, can you see this? Smaller than the expected and bigger than expected. That suggests that the solution will be between 2.8 and 2.9. So we have got another number line or another interval which will be between 2.8 and 2.9. Let us figure out the numbers between 2.8 and 2.9. We have 2.8 here and 2.9. So here we have to try the number exactly at the middle, the number which is halfway 2.8 and 2.9. This is 2.85. Okay, so we have to try 2.85. 2.85. Okay, so calculate the value of y when x is 2.85. We get 16.6725. 6725, which is smaller than the expected. And then because it's smaller, we have to go higher than 2.85, and we get the number higher than 2.85, that is 2.86. We try that. 2.86. What is the answer? We get 16.7596. 16.7596, which is still smaller than the expected. It's still smaller than expected. Then try 2.87. So let us try 2.87. We are getting 16.84. 16.8469, which is still smaller than the expected, smaller than 17. And let's try 2.88. So try 2.88. We are getting 16.93, 16.9344, which is still smaller than 17. And we are going to try 2.89. 2.89. Try 2.89. We are getting the number bigger, so we stop there. 17.020221. which is bigger than the expected. Now this suggests that so you have to close the boundary, close this table here, right? And this suggests that the value of x will be 2.88 to 2 decimal places and 2.89 to 2 decimal places. Now, because we are told to round off, we are supposed to leave the answer correct to 1 decimal place. We are told to leave the answer correct to 1 decimal place. So you can see that when you round 2.88 correct to 1 decimal place, the answer will be 2.9. When you round 2.89 correct to 1 decimal place, the answer is still 2.9. So this suggests that therefore x correct to 1 decimal place will be equal to 2.9. And this is the final answer. Alright, let us proceed. Show this inequality on the number line. We have this inequality here, x is bigger than 3. So we are looking for the numbers which are all the way bigger than 3 on the number line. Okay. Now the starting point will be at number 3 itself, and this symbol suggests an open circle. So you just make an open circle just above 3, and then you take a ruler, take your ruler, draw the numbers, draw the line which is all the way bigger than 3. Okay, so from here you'll be heading to the right hand side. On that place is where you find all numbers which are bigger than 3. So here all the numbers bigger than 3 are represented by that line here. Okay. So these are all the numbers which are bigger than 3, right? Let me use a heavy line over here. Okay, all the numbers, these numbers here are the ones which are bigger than 3. Alright, let us proceed. We have done this page, and then let us move on to the next page. Okay, the next page is here. This question is talking about x and y. X and y are two positive numbers. So I can assume x to be equal to any positive number, for example positive 2, and I can assume y to be equal to any positive other number, say positive 4, for example. Okay. Then here are some statements. Statement A says x times y is bigger than 0. Statement A is saying x times y is bigger than 0. Okay, let us say x is 2 times y is 4. We are getting the answer 8. Now when you compare this answer with 0, you find that 8 is bigger than 0. See? So this is true. We say this is always true, that when you have a positive number multiplied by another positive number, the answer is expected to be bigger than 0. Okay, this is always true. Alright, now how about x times y? X times y, x is 2 times y is 4. Okay, do we think that this answer will be equal, would be less than the value of x? But over here the value of x is 2. Okay, so 2 times 4 is 8. Now do you see that 8 is less than 2? This is false. This is not true. Okay, so B we say B is sometimes true, never true. So we say B is never true. So B is never true. Okay, it's never true. Suppose we do this one here, 4 times, okay, C. C is x divided by y is less than y. Let us see, x is 2 divided by y is 4. Now is this going to be less than the value of y? This is going to be less than 4. Let's see, 2 divided by 4 is half. 2 divided by 4 is half, or 0.5. Now is 0.5 less than 4? Yes. Okay. What if you exchange here? Maybe let us say x is 4 and y is 2, for example, and do the same thing. X divided by y. X in this case will be 4 divided by 2. Is this going to be less than y? Y is 2. This is 2. So we can say this is sometimes true. So C is sometimes true. Okay. All right. Let us see the last option here. We said let x be equal to 2 and y let it be equal to 4. And let us do x divided by y. X is 2 divided by y is 4. Okay, 2 divided by 4, this is 0.5. Now is 0.5 less than 0? This is false. 0.5 is not less than 0. Suppose you exchange these values and make x is 4 and y is 2, and do the same operation. This will be x is 4 divided by 2. X is 4 divided by 2. 4 divided by 2 is 2. Now is 2 less than 0? The answer is still false. 2 is not less than 0. So here we say D is never true. So here we say D is never true. Okay, you can drop me a message if you still have a problem over here. But otherwise, let us proceed. Let's go to this page here. Write one of these symbols in each gap. Write one of these symbols in each gap to make a true statement. We have less than over here, we have greater than, and we have is equal to. We'll be using those symbols to complete this sentence. The first one has been done for you. Let us see, 24 divided by 2, 24 divided by 2, this is 12. Now, when 12 compared with 24, we find that 12 is less than 24, so the example is correct. Now, let us do 56 times 1.02. Okay, this, to multiply this, you can use a calculator, or you can do it mentally. Okay, so using a calculator, we have 56 times 1.02. You'll get 57.12. Okay, now suppose we don't want to use a calculator, what will be the answer, or what will be the working? We have 56 times 1.02. So what we do, you ignore this decimal point, you ignore that, then you take the number as 102, multiply by 56. So you do vertically, and let us do it together and see what will be the answer. 6 times 2 is 12, carry 1. 6 times 0 is 0 plus 1, this is 1. 6 times 1 is 6. 5 times 2 is 10, carry 1. 5 times 0 is 0, add 1. 5 times 1 is 5. Okay, so when you add that, you are going to get this is addition. So there are 2 decimal places over here. So 2 decimal places, that means count 2 numbers, 1, 2, hit a decimal point over here. So 56 times 1.02 is 57.12, and this is what we have here on the calculator, 57.12. Now when you compare with 56, you find that 57.12 is greater than 56. So here you put that symbol. You can pause the video and try the remaining other questions, but otherwise let us proceed. Okay, we have 16 times 0.2. Ignore the decimal point, just do 16 times 2. The answer will be 32. You have one decimal place over here, so count one number from the right, and this becomes 3.2. Now 3.2 compared with 16, you find that 3.2 is less than 16. So here you write less. 3.2 is less than 16. Okay, another one is 35 divided by 0.55. You can do it mentally or use a calculator. If the question is in paper 2, you can use a calculator. But if this question is in paper 1, you have to use your mental capability. Okay, this will be 35 divided by 0.55. Set that division as a fraction, so this will be 35 over 0.55. And you can see that we have two decimal places, so this will be multiplied by 100 over 100 to remove the decimal places. So 35 times 100 is 3500. Divide by 0.55 times 100 is simply 55. Okay, so you can just simplify this by 5. This is 700 by 5. This is 11. Okay, 700 divided by 11, you do 700 divided by 11, you are getting 63.63. So over here, this is 63.63 carrying. Okay, so when you compare with 35, you find that 63 is higher than 35. So the symbol, that is the symbol you put it. Okay, let me delete this so that I can remain with clear answers. Alright, so this one is done, like so. Okay, now let us compute this. We have 40. We have 40 times 0.4 divided by 0.4. So what do we do? We have to work out the numerator. 40 times 0.4. So 40 times 0.4. Ignore the decimal point. So just do 40 times 4. This will be 160, and you have one decimal place over here. So one decimal place. That becomes 16. So the numerator is 16. Divide by 0.4. So take out the decimal point by multiplying by 10 over here, multiply by 10 over there. So this will be 160 over 0.4 times 10. This is 4. By 1 by 4, this will be 40. Okay, so we have 40. We have 40 here. Compared with 40, you find that 40 equals 40. So the symbol which is supposed to be put here will be is equal to. Okay, you can pause the video and take some notes. Otherwise, let us proceed with the next party. Okay, we have, this is a trial and improvement. Okay, here we are looking for the value of x, which when raised by 3 minus 2x, the answer is 40. Okay, let me check how many minutes have gone. We have just gone by 29 minutes. Okay, one solution of the equation lies between 3 and 4. Okay, use the method of trial and improvement to find this solution to one decimal place. Show all you are working in the table. You may not need to use all the rows. Okay, good. So what we are going to do is pull out your calculator and save this function in the calculator. We have to save this function in the calculator. So the function is x power 3 minus 2x equals to 40. So ignore this equals to 40, and then store x power 3 minus 2x. So you do alpha y equals to then we have x power 3. Okay, so that will be x power 3 alpha x power 3 shift. Okay, this is x power 3, then minus 2x 2 alpha x. Okay, now let us calculate. Let us first check when x is 3. What do we get? Calculate. Try x equal to 3. We got 21. So their example is correct. Try x is 4 equals to 56. Okay. Now 56 is higher than 40. Now that suggests that the solution for x lies between 3 and 4. Okay. Now let us try the numbers which are between 3 and 4. So try the numbers which are between 3 and 4. So here we'll be trying the numbers which are between 3 and 4. So those numbers are, we have 3 here, we have 4 here. So the numbers which are between 3 and 4, try the number which is halfway, which is exactly halfway between 3 and 4. That number is 3.5. Okay, so you try 3.5 over here. Okay, now try 3.5 in your calculator. Try 3.5 and see the number you are getting. So we are getting 35 points. We are getting 875. And when you compare with 40, you find that that is too small. So you write here too small. Okay, now since it's too small, we have to go higher than 3.5, and this is 3.6. Do that. Calculate. Try 3.6. You get 39 points. You get 39.456. 456. So still that is too small. And when you try 3.7, what do you get? Okay, try 3.7. We are getting the number higher. We are getting 43.253, which is too big. So you're right, this is too big. Now this suggests another new interval, which is between 3.6 and 3.7. Okay, so take this, suggests another new interval that is between 3.6 and 3.7. So here try to check the numbers which are between 3.6 and 3.7. Try that. Okay, 3.6 and 3.7. Alright, okay, so try the number which is exactly halfway between 3.6 and 3.7. This is 3.65. Okay, 3.65. So when you try 3.65, put it over here, 3.65. Try it using a calculator. So try 3.65. We are getting the number which is bigger than 40. So we are getting 41. We are getting 41.32. 7125. 7125. Okay, what does this suggest? This suggests that this answer is too big. Now, since we tried 3.65 and we got the number or we got the result which is bigger than 40, so we have to try the number below 3.65, and that number below 3.65 is 3.64. Okay, so try 3.64, try 3.64. We get still 40.94 8544. Still, this is too big compared with the expected, that is 40. Now you have to go lower than that. This is 3.63, and try 3.63. Try 3.63. Still, we are getting the answer which is higher than the expected. We got 40.57. 2147. Still, this answer is too big. Try 3.62. So try 3.62. We are still getting the number which is higher than that, 40.197. 928. Still, this is too big. And then try 3.61. Try 3.61 is equal to 39. So there you stop. So 8258, and then 81. Okay, 81. We got the number which is too small. So too big, too small. This is a contradiction which has to stop over here. And then our answers will be between 3.62 and 3.61. Now, since we are told to round the answer correct to one decimal place, so our answers will either be 3.62 and 3.61, but when we round this correct to one decimal place, the answer will be 3.6. Round to one decimal place, the answer will be 3.6. So can you see that the answers over here are the same? So 3.6 is the value of x. So x equals to 3.6, and this will be the end of this page. Okay, let us try to see the next page. The next page is this page here. Okay. All right, we have this page. Calculate the value of x plus 5, x minus 4 when x is equal to -3. This will be calculate the value of x plus 5, x minus 4 when x is -3. Okay, so in place of x we write -3 plus 5. In place of x we write -3. That means we are substituting x equal to -3 in this expression here. So -3 plus 5, this you can, switch the numbers around. This will be 5 minus 3. And this is -3, -4, even the answer will be negative number, and this will be -7. Can continue over here. 5 minus 3 is 2, and -7. So 2 times -7, the answer is -14. See that? All right. Now we have this question over here. We have this question over here. All right. Let us proceed. So we have this question here. X plus 5, x minus 4. X plus 5, x minus 4 equals to 286. Use trial and improvement to find the positive solution of this equation. Show your trials in the table. You may not need all the rows. One value has been done for you. Okay, so what we are going to do is take that x plus 5, x minus 4 equals to 286. So what we basically do, we ignore equals to 286, and then we save our function in the calculator. X plus 5, x minus 4. Okay, so this becomes our y. This becomes our y. So you take your calculator, and save that. So we have, let me put the calculator over here. Okay, so alpha y equals to bracket x plus 5. So alpha x plus 5. Then alpha x, alpha x plus 5, x minus 4, okay, right. Let us check x plus 5, x minus 4. This is our function. It has been saved in our calculator. So now let us calculate the trials, and the answer should be equal to 286. Okay, so let us try. Okay, now calculate try x equal to 10. We got 90, and this is their trial. Okay, now since we got 90 and we were expecting to get 286, so we have to go higher than 10. So try the number higher than 10, that is 11. So try that. Try 11. We are getting 112, and this is suggesting to be too small. See that? Too small. And try 12. Try 12. Try 12. We are getting 136. This is still too small. Try 13. Try 13. 162. Still this is too small, because we are looking for something equals to 286. We are looking for something equals to 286. Okay, so try x14. Try x14. We are getting 190. Still this is too small. Okay, then try 15. Try 15. We are getting 220. Still this is too small. Try 16. 16. 252. 252. Still this is too small. And then we have to try x equals to 17. Try 17. We are getting 286. 286, and this is perfect. This is perfect. And because we were looking for something equal to 286, we got that. So this is the value of x, which we have to conclude over here. X equals to 17. That is exact. Alright, let us proceed. We have already figured out the value of x. So let us continue with the last question. Use a trial and improvement method to find an approximate solution to the equation. start with x equal to 7 to see which value of x will be substituted into this equation, and will give you something equal to 400. Okay, give your answer to one decimal place. You must show all your working, right? So what do we do over here? We have to ignore that and save in the calculator y equals to x to the power of 3 plus 5x. Okay, so pull out your calculator and save that function. Okay, alpha y equals to x to the power of 3 plus 5x. Okay, now let us start with trying the values. Okay, the function is already here in our calculator. Okay, so what we are going to do is start with x equal to 7. All right. So if we start with x equal to 7, so try x equal to 7. What is the value of y? Okay, we got 378. So 378. These will be our comments. Now, the comments which I will go for, let us say smaller. Let us use smaller or bigger than 400. Okay, we'll be going for that. Okay, so smaller than 400 or bigger than 400, those will be our comments. Okay, let us proceed. Let us try now. Start with x equal to 7. Now, since we got a number, we got a result which is less than 400, so we have to go higher than 7. That is 8. So try x equal to 8. So try 8 and see what you are going to get. 552. So 552, this is a result which is bigger than the expected. So this was smaller and this is bigger. Now, when you get this contradiction, one is saying smaller, another one is saying bigger, so that indicates that the value of x lies between 7 and 8. So you draw a number line to show your interval, that this interval, that our solution lies between 7 and 8. So our solution lies between 7 and 8. So try the number exactly halfway between 7 and 8. That is 7.5. Okay. So try 7.5 and see how much do you get. Okay. So try 7.5. 7.5. Okay. So we are getting 459. We are getting 459. Let me check it again. X power 3 plus 5x. So calculate 7.5. Okay, 7.5. We are getting 459. We are getting 459. 459.375. Now, when you compare with 400, that is said to be bigger than 400. Now, since 7.5 has given us the bigger result, so we'll be trying numbers which are less than 7.5. That is 7.4. So try 7.4. Okay, try that. Try 7.4 and see what you are getting. You are getting 442. 442.224. But still this is bigger. So we have to go for 7.4, go to something less than that. This 7.3. Okay, try 7.3. Try 7.3 here. Okay, try 7.3. We are getting still bigger. 425.517. 517. This is still bigger than 400. So try 7.2. Try 7.2. This is still 400. 409.248. This is still bigger than 400. Still bigger than 400. So try 7.1. Try 7.1. 7.1. Oh, we got something smaller than that. Okay, 393.411. Now this is smaller. Now getting smaller, this is bigger, and that is smaller. So this suggests that our solution will lie between 7.2 and 7.1. So that is a new interval which you will have to try. So try that. Put your number line over here. Okay, then try all of the numbers which are between 7.1 and 7.2. Okay, so here you try 7.15, the number which is exactly half. So try 7.15 and see what you'll be getting. Calculate that. 7.15 equals to a number bigger than 400. Got 401.2758, and then 75. Okay, 7.5. Still this is bigger. That is bigger. So we tried 7.15. We got something bigger than 400. So since we got something bigger than 400, you have to try the number lower than 7.15. So that is 7.14. Okay, try 7.14. 7.14. Try that. We are getting the number smaller. We are getting 399.69. 4344. So this number of that result is smaller than 400. Now since we have got the second contradiction, bigger, another one smaller, so there we stop. Okay, so there we stop. Now our answer is 7.15, 7.15, and 7.14. But when we round this number, when we round this 7.15 correct to one decimal place, you'll be getting to one decimal place, you'll be getting 7.2. When you round this answer to one decimal place, you'll be getting 7.1. Now, which one? Because we were expecting us to get same answers, but we are getting 7.2, 7.1. Now, to know which one do we go for, you just take the expected answer. The expected answer, we're expecting 400. We're expecting 400, but here we got 401.275875. So you have to check this 401 is bigger than 400 by how much, and then you do comparison. So you take 401.275875. You minus with 400 and see What is the difference between those two? Okay, that is bigger by, it is bigger by this answer here. This answer here is bigger than 400, is bigger than 400 by, is bigger than 400 by 1.27, 1.27, 1.27, 5875 is bigger than 400 by 1.275875. Okay, now let us see this answer here. This answer here is smaller than 400 by how much? Okay, so you take 400, minus 399.694344. Alright, so this one is smaller by, this result is smaller by 0.305656. So you can see that this answer 7.14 is giving 399.694344, which is smaller by only 0.305656. So this answer is at least approaching 400 when compared with 401. So this 399 is going to be a better estimate, because this 399 is pretty close to 400. Okay, so our answer will not be 7.14, will be 7.14, which equals to 7.1 correct to 1 decimal place. I hope that helps. Then you can pause the video and take the notes. So x equals to 7.1. All right, thank you very much for listening to me, and I'll be back for the next other sessions. All right, thank you very much, and bye bye for now. All right, see you.